This is a video from section 1.2 in a linear algebra class. The directions say to solve the following system using Gaussian elimination. So this is my system of equations. We get x plus y plus 2z equals 8. Negative x minus 2y plus 3z equals 1. And then 3x minus 7y plus 4z equals 10. So what we need to do is we need to write an augmented matrix. So to do that, I'm going to look at the coefficients of x, y, and z in the first, second, and third row to get my corresponding entries within this matrix. So in the first row, we're going to get 1, 1, 2. So notice the coefficient of x is 1 in the first equation. The coefficient of y is 1 in the first equation. Coefficient of z is 2. And then I'm going to tack on an 8 at the end. Now in the second row, I'm going to put negative 1. That's the coefficient of x in the second equation. And then negative 2. 3, and then I'm going to put a 1 here because that's what that left side is equal to. In the third row, I'm looking at the corresponding third equation, and I'm going to put 3, negative 7, 4, and 10. Now, I want the first entry in the first row to be a 1. That's called my leading 1. And I'm going to use the first row in order to get this number in the second row to be a 0 and this number here in the third row to be a 0. That's my strategy. So I want this number in the first row to be a leading 1. So now, to get this negative 1 to turn that into a 0, I'm going to take row 1, add it to row 2, and I'm going to put the result back into row 2. Now, I need to turn that 3 into a 0. How do I do that? I'm going to take negative 3 times the first row. I'm going to add it to the the third row, and I'm going to put the result back into that third row. And when I do that, I get the following. I get 1, 1, 2, 8. So that first row doesn't change. In the second row, I get 0 by design, right? And then if I take 1 minus 2, I get negative 1. And then 2 plus 3 is 5. And then 8 plus 1 is 9. In the third row, I get a 0, again by design. And in the next one, I'm going to take negative 3 times 1 and then subtract 7 to get negative 10, then negative 2, and negative 14. So now, in the second row, I need the first non-zero entry to be a 1. Again, we call that a leading 1. How do I do that? I'm going to take negative 1 times the second row, and I'm going to put the result back into the second row. Now, look what happens. The first row doesn't change. I get 1, 1, 2, 8. In the second row, I get 0, 1, negative 5, negative 9. So every entry in the second row takes the opposite sign. In the third row, I get 0, 10, but that's negative, negative 2, negative 14. Now, I want to use row 2 now. This is my strategy. I want to use row 2 to turn this entry in the third row to be a 0. So how do I do that? So, and this is how row echelon form works. So I'm going to take 10 row 2, I'm going to add it to row 3, and I'm going to put the result back into row 3. Okay, and so from here, I get 1, 1, 2, 8, 0, 1, negative 5, negative 9, 0, 0, right? And then 10 times negative 5 is negative 50. Negative 50 minus 2 is negative 52. And then 10 times negative 9 is negative 90. Negative 90 minus 14 is negative 104. And then one final step is I need this number, that's the first non-zero entry in the third row, to be a 1. And so I'm going to take negative 1 over 52, row 3, and I'm going to put the result back into row 3. And when I do that, I get 1, 1, 2, 8, no change, 0, 1, negative 5, negative 9, 0, 0, 1, 2. Now, we're in the home stretch. So we get x plus y plus 2z equals 8. That's the first equation. The second equation will be y minus 5z equals negative 9. And then the third equation will just say z equals 2. So now we can solve this by what's called back substitution. So I'm going to take z equals 2 and plug it into this second equation and solve for y. So y minus 5 times 2 equals negative 9. So y minus 10 is negative 9. So y is 1. Okay, so we have z is 2 and y is 1. Now I'm going to take my values for y and z, and I'm going to plug it into the first equation and solve for x. So x plus 1 plus 2 times 2 equals 8. X plus 5 equals 8, so x is 3. And so my solution is the ordered triple 3, 1, 2. Now it doesn't hurt to check. So this is what my system looks like. X plus y plus 2z equals 8. Negative x minus 3y plus 3z equals 1. And 3x minus 7y plus 4z equals 10. So if I replace x with 3, I get 3. Replace y with 1, I get 1. Replace z with 2, I get 2 times 2. On the left side and on the right side, I get 8. That absolutely works. Go to the second equation. Negative 3 minus 2 times 1 plus 3 times 2. Does that equal 1? And I would submit to you that the answer is yes. And then 3 times 3 minus 7 times 1 plus 4 times 2. This is equal to 9 minus 7 plus 8. And that absolutely equals 10. And so the solution does indeed check out. And so that's how we solve that system in the first example. Now, let's take a look at this second example. Suppose I give you the following. 2x1 plus 2x2 plus 2x3. This is equal to 0. And then we have negative 2x1 plus 5x2 plus 2x3 equals 1. And then 8x1 plus x2 plus 4x3, this thing is equal to negative 1. And so we need to set up our augmented matrix. What does that look like? In the first row, we get 2, 2, 2, and then 0. The second row, we get negative 2, 5, 2, and then 1. And then in the third row, we get 8, 1, 4, and then negative 1. And so remember what I said in the last example. If we look at the first entry in the first row, I want that to be a 1. The question is, how do I get that to be a 1? And the way to do that is I'm going to take row 1 and multiply it by 1/2. Okay? And so what does that look like? Well, in the first row, we get 1, 1, 1, 0. In the second row, we get negative 2, 5, 2, and then 1. And in the third row, we get 8, 1, 4, negative 1. Just like this. Okay? So where do we go from here? Now, I want the entry in the first entry in the second row and the first entry in the third row to be a 0. And I want to use row 1 to get me there. Okay? So how do I do that? I'm going to take the first row and multiply it by 2. I'm going to add it to the second row, and I'm going to put the result back into the second row. Then I'm going to take negative 8 row 1, right? Because I want to use row 1 to turn that 8 basically into a 0. I'm going to add it to row 3, and I'm going to put the result back into row 3. So what does that look like? Well, I get 1, 1, 1, 0 for the first row. That doesn't change. By design, I get a 0 here, and then I'm going to take 2 times 1, I'm going to add it to 5, and I'm going to get a 7. And then 2 times 1 added to 2, I get a 4. And then I get a 1. Then I get a 0 here in the third row. Then I'm going to take negative 8 times 1, add it to 1. I'm going to get negative 7. And then negative 8 times 1, add it to 4. And I'm going to get negative 4. And then I get negative 1 for the last entry. Now notice, the entries in row 2 are the opposite of the entries in row 3. So this is what I'm going to do. I'm going to take row 2, I'm going to add it to row 3, and I'm going to put the result back into row 3. Okay? Now, when I do that, watch what happens here. I get 1, 1, 1, 0, 0, 7, 4, 1. And remember, I want the row of zeros to occur at the bottom of the matrix. So here I'm going to get 0, 0, 0, 0. So notice how the row of zeros are at the bottom, but the first non-zero entry in the second row has to be a 1. That's a 7. That's no good. And so I'm going to take 1/7 row 2. I'm going to put the result back into row 2. Watch what happens. I get 1, 1, 1, 0 for the first row. Then I get 0, 1, 4 over 7, 1 over 7. And then I get 0, 0, 0, 0. And we're now in the home stretch. Okay. So So I want you to watch carefully how this works. So I'm going to get x1 plus x2 plus x3 equals 0. Then I'm going to get x2 plus 4/7 x3 equals 1/7. Now, this is what I would do. What I'm going to do is I'm going to let x sub 3 equal t. We call that a free variable, okay? Then I'm going to solve for x sub 2. X sub 2 plus 4/7 t equals 1/7. And so if I solve for x sub 2, I get x sub 2 is negative 4/7 t plus 1/7. That's x2. That's x3. Now, x1 plus x2 plus x3, this is 0. So x1 plus, and then remember, in parentheses, I got negative 4/7 t plus 1/7, okay? Plus t, that's what x3 is, equals 0. So what this says is x1 plus 3/7 t. So let's just remind ourselves, 1 minus 4/7 is 7/7 minus 4/7. But that's 3/7. And so I just took this term and this term and combined them. Then I'm going to add 1/7, set this to 0. So x1 is negative 3/7 t minus 1/7. And then I have a general solution here, right? So my general solution can look like this. x1, x2, x3, right? So I'm going to get negative 3/7 t minus 1/7. That's x1. x2 is negative 4/7 t plus 1/7. And then I get t for the third column, or third component. And I would leave it there. And that'll conclude this video. So what I did was I took two matrices and took two augmented matrices and reduced them, right, to help me solve systems of equations. Okay, thank you.